And we're live. Okay. For the first time in Lord knows how long, I am not only on time but early for my stream. So yeah, this is day 100. Did I change the number? Day 114. I hope this is the correct number. Let me check. If this is not the correct number, that'd be really awkward. But let's see. Okay, it is the correct number. Okay, day 114 of setting compilers every day until I land a compiler rule. Last time we added a couple more LEA tiles. This time I hope to finish that set, and then we could probably add a couple other additional tiles and then kind of just call it done for tree tiling, to be honest. I have this all in Notepad. I got a couple comments asking why I use Notepad, and that is a very good question. I don't have a good answer for that. Yeah, I just kind of decided to use Notepad for some reason. Now that I think about it, this is not going to be a valid tiling in any instance, so we're not going to cover that. We will cover this though, just like some very basic things. Yeah, I think just that and then like this stuff is probably good enough. We could do some like shift op stuff, but I don't particularly feel like doing anything too complex, so I think we'll just finish up LEA and then add this case, and then we'll just call it a day for tiling. In terms of where we are on the back end as a whole, we have like assembly sort of generated now. From here, all we need to do is we need to do regalloc, so we're allocating registers. Right now we have like variables still, but we only have so many registers in the hardware, so we would want to map that down in some way. The historical preferred way of doing this is like tree tiling, or not tree tiling, graph coloring. I might redo that. I might also like look at what LLVM does, because I know they don't do graph coloring. So we'll have to see, I guess, what we do with that. Yeah, and then at that point, we technically do just have assembly, I think. There's like a little bit of small cleanup stuff we need to do, but that's pretty minor, I think, at least. Something else I'm thinking about is maybe moving all the preamble stuff out of, or like putting the preamble stuff somewhere else that isn't just like where it is right now, because we generate a lot of stuff without, I guess, having complete knowledge of what we need. So yeah, it seems a little bit suspect to leave it as is. What's good, Jan? Good to see you. Okay, so let's tile these at least. Okay. So let's go to the back end. So this is in tree tiling once again. Yeah, we've got a whole pile of tiles here. I should probably rearrange these in some way, but whatever. Yeah. Okay, so the tiles we want to add are like, instead of doing 1, 2, 4, 8, we're doing like, I guess, 3, 5, and 9, which are 2 plus 1, 4 plus 1, and 8 plus 1. I'm not gonna worry about 7 and 6 for now. What's good, Niraj? Good to see you. So the way we're gonna tile this is we're actually just gonna treat it as like reg plus reg times 2, or 2, 4, or 8 here. And then we can also do that with immediate as well. Yeah, so we're gonna give that a try. Just working. Start 3D OpenGL. Ooh, fun stuff. Okay, how do I even generate the tile for this? I guess the one we're stealing here is just the IS tile, because we have the index and we have the scale. So the other question is, how do we give this like a distinct name in a way that's like kind of interesting? My proposal is we have index scale. This is not confusing whatsoever, surely. But yeah, index we can just reuse pretty much, and yeah, hopefully the the tile will look a little bit more interesting than what we've gotten so far. Actually, it will not look more interesting now that I think about it. Leis tile. Okay. So we're just gonna put this under here for now, and then we can rearrange stuff later once we get closer to done with everything. Actually, we need to yank word. Like that. Okay. Okay, so we got tile. Matches we'll do in a second. This apply will be kind of funny actually, because we're just duplicating index into base pretty much. What's your keyboard? It's a Keychron V3, I think. It has Gateron Oil Kings and MT3 profile keycaps. Okay, we can copy this, but we need to be a little bit more creative with it. Instead of this, we wanna. I think we can just copy this. But instead of that, I think we can just base. Yeah, we can just copy that. Life is good. Okay, let's static cast. Do we need to static cast that actually? I could probably just static cast it once up here. My neighbors are being quite loud, so that's rather inconvenient for me. Yeah. So yeah, y'all will have to deal with that, unfortunately. For better or for worse. Hopefully this does not get me demonetized. Okay, so we have a register now. So we've copied that. We can also just get rid of the static cast in here now. Sick for a week, but got SSA done. Ooh, good stuff. Okay. Yeah, okay. I think that's all we need for this, to be honest. Yeah, okay. So now we just need to match the thing, which I think we can just copy all of this, but we can change the numbers around. Yeah, that should be pretty safe. Yeah, let's just get rid of that. Let's make this 3 and then 5 and then 9. And then I think we're good, to be honest. I should probably make the tests. How's the backend going? I think we're almost done with instruction selection, which I guess this has taken way longer than it should have. It's been like, what, 40 episodes? Or like 40 days? Yeah, I mean, yeah, it's a wonder how like in our compilers class I was able to do this in 1 week even. I guess I didn't really understand it fully, so I guess I've done the learning now. So I do actually know what's going on now, finally. Let's make the tests real quick. Let's go to LEA. Yeah, I need to reorder these in some way. Should I just alphabetize these, or should I like? I could group all the 2s together. Yeah, let's reorder this a little bit. Yeah, so that's all the 2s, these are all the 3s, and then that's the 4. Okay, so we can copy this. And then we can... Where do we even put this? That kind of breaks my naming scheme, actually. That's really annoying. Because we're not really alphabetizing, I guess. I guess it kind of fits here. Yeah, we'll just do that. Yeah. Let's do 3, let's do 5, let's do 9. 3, 5, and then 9. Okay. Also, while I'm at it, I may as well fix these names. I don't know what I was doing there. Okay. I think that's everything. Okay, cool. So let's run tests, regression, generate tests. Okay. So this is update regression, or I guess clean up LEA tests plus add pre-commit test for IIS tile. Backends are most mysterious part of compilers. Yeah, I think just the closer you get to hardware, I think in general, you kind of are just forced to make more of a mess. And I think like OS is like a pretty good example of where that happens, but I think like that also holds pretty true to like compiler infrastructure as well. Okay. So let's, I guess, well, yeah, let's make having a table that has squares on it is useful because it's a graph of itself. Oh, I see what you're saying. Yeah, that does sound quite nice. Yeah. Yeah, I don't know. I imagine you could also like, or like, why doesn't graph paper just like, or like not like, why don't you just use like a graph paper notebook, I guess. Okay, let's see what changed. Nothing changed. Wait, what? Oh, I didn't add the, I always do this. I forget to add the tile every time. Yeah, let's go down here. I think I could just put this here. Yeah, okay. Yeah, this ordering makes sense to me. Yeah, and then we can just reuse code. Life is good. Okay. Okay, what changed? That's not what's supposed to happen. Oh, I know why that's not supposed to happen. Yeah, okay, I forgot to subtract one. Where's this tile again? Huzzah, okay. Okay, so we want get value, and then we want just -1 here. Yeah, so let's build this. I think that's the most scalable way to do this as well. Someone is getting thrown around. Holy shit. Anyway. Yeah, let's diff this again. Okay, we get the correct numbers now. So we have implement LEAIS tile. Okay, cool. Real quick, I wanna figure out how I'm ordering everything. I think the ordering between the tests and this are inconsistent. So I'd like to fix that real quick. I kind of like this ordering here. Or I could also like move things around in the other direction. I don't know. It doesn't matter, to be honest. But it matters to me. we're gonna rearrange things. Okay, let's just split so it's easier for me to work with this. So BI tile there makes sense. I think I should move IS tile up. Yeah, so let's put that here. Paste downwards. Okay, so then we have BIS tile, BID tile. IIS tile is fine, I think. I don't know, this one feels weird leaving here. I feel like it kind of falls under the 2 section. Yeah, so I think I'll just throw this here. Okay, I think the rest of the ordering is fine here. So let's just reorder it here as well, just for consistency. So yeah, IS tile. Okay, so we can delete that. BID, BID, BIS, it should go here. Okay. BIS, BIS, BID. And then this stuff we should probably move upwards. Okay. So this goes like here probably. Yeah, okay. Yeah, okay, that seems reasonable enough to me. Yeah, okay, cool. Let's just build just in case. I don't think this is gonna change anything, but maybe I should have like op levels for these tiles actually. That would be interesting. I probably should do that. Order existing tiles a little. Looking at me. Funny. Okay. Also the name of the test generator is low-key kind of long and it's really annoying. So maybe we could just do this like generate, I guess? Or like update. Gen tests, I guess. I don't know. The problem is all 3 of these words feel like they're I need like each of these words, so I can't like rename this in any meaningful way, at least. Whatever, I'll leave it. That bugs me a little. Okay, so that's this tile done, or I guess that tile. So the only one we need to do is just that one plus an immediate, which, well, shouldn't be that bad. We can just reuse infrastructure once again. There's a lot of copy paste happening, but it's reasonable, I promise. Yeah, okay. Let's go do backend, or yeah, backend. Let's just go here again. So we have ISD tile, so we want IISD tile, I believe. Yeah, okay. And then we can just reuse stuff for that again. Actually, we duplicate this code once, right? Yeah. We could probably encapsulate this in a helper function as well, but Yeah, I mean, I don't really care, honestly. So we want to copy ISD tile. Oh, that is not how you spell it. Okay. So we can kind of just copy all of this real quick. Okay. PC specs, I don't remember off the top of my head. I have a, I think that's a 4070 Super, 32 gigs RAM. Let me check without leaking everything. I have a Ryzen 5 7600. And this is honestly way more than enough for pretty much anything I've needed. It's a little bit dusty, but it is what it is. Okay. Let's do that. Oh, I can't reuse this. That's annoying. We cannot match scaled index, actually. Okay, we're gonna need to rewrite some stuff, I fear. Okay, let's... What do we do here? Actually, wait. Wait, I literally match scaled index here, actually. I could just simplify that out real quick, actually. Maybe I should just write the helper first, huh? Okay. What do I even pull out of this? Okay. Okay, let's do like... Let's just copy all of this again. And then we can call this like +1. We can just do that. Or scaled +1 index. Yeah, we'll rename it in a second. I promise it'll suck less. Okay, 3, 5, and not 0. Okay, we can do that. Yeah, we can just do that. Okay, so we want scaled +1 index. Yeah, we can do that. And then IISD tile. We can just copy... where the hell is it? Really? I don't have that? Where is this? Oh, wait. Yeah, this thing here. So we can just paste over that. And we can reuse all of that. And then we can get rid of the cast there, and then life is good. This inspirational, I can't speak English. I'm trying to learn graphics programming, so this is good motivation. Yeah, I mean, hopefully this also encourages you to set aside a little bit of time every day, just to like focus on like your personal projects / like learning independently. Okay, let's make the test real quick. Oh, wait. I didn't forget this time. I didn't forget. Huzzah. Almost forgot. Are you already a Swede? why do you want to get into compilers and what are you making? So currently I'm a student. I'm finishing up my undergrad degree and I guess starting my master's at the same time. And I just think compilers are really cool. They combine a bunch of different areas of computer science that I find interesting, which is, I guess, why I want to work on them. Right now I'm working on a compiler from C to x86-64, and the goal is to remake a lot of the existing compiler infrastructure, I guess. So like re-implement it from scratch pretty much. Okay, let's be more interesting with this one. We can just copy this, but instead of using hard-coded scale, let's just put numbers in. So let's do 3. Let's do 5, and let's do like 9, and then let's do 3 again. Why not your own language? Because I want to be able to benchmark it against the large production compilers, and then I can, I guess, just from a resume perspective, that gives me like something more interesting at least. And also it's just like really fun to, I guess, compete against what already exists. And also I don't really see an instance where I want to make a language at least, or at least I don't really have any great ideas yet. Okay. So we can run tests and generate regression tests. Alright. That's not interesting. That's a little interesting. Yeah, so we make a mess, which, yeah, sure. Yeah, okay. That's completely expected. Okay. Pre-commit tests for LEA, or LEA IISD tile. So let's build real quick. And then we can rerun the test generator and then everything should look good. The reason why I'm trying out this like pre-commit testing, it's not even like because I care about TDD whatsoever. Obviously, I'm like, I'm doing these tests like after. The nice thing is because now I can get diff test and then I can see what has changed in the output. And it looks like I forgot to subtract again. God damn it. Okay. ISD. Here we are. Yeah, so this I think is a little bit less unwieldy of a way to check tests, at least. Have you gotten lost in the large scope of your own project before? Yes, 100%. I have looked at a bunch of old to-dos before and been like, what does this mean? And also like it's very easy to like accidentally re-implement things that you've already implemented. Okay, this looks correct. Implement LEA IISD tile. Okay. All right, let's do the refactor thing that I wanted to do real quick. Okay. How do we even do this? So we have match scaled index. I think this duplicative stuff at the top is pretty reasonable. I would like to rename these though. So we can just rename match SI. We can match like SSI. Okay. There's another place where I duplicate code somewhere. Yeah, it's this thing. yeah, let's figure out what to do here. Match SI. Yeah, okay. What was I doing here actually? Oh yeah, because we need to, yeah, okay. Match SSI, or, yeah, like that. Where is this again? This is BISD. That's not the one I care about. Okay, that doesn't help me at all, actually. Do you document your code religiously to avoid it? Honestly, no. I try to write my code in a way that doesn't require documentation. That's why I've been like avoiding comments as much as possible, unless it's like something I literally cannot avoid with a giant function like this, for instance. How hard is it to get a compiler rule? I mean, it's no different than like getting any other SWI rule. I just have to typecast myself properly, pretty much. Okay. Where am I? I try to avoid comments because they don't change with the code. So if I end up making a change that requires me to change the comment, there is a chance I forget to change the comment. It turns out comments are great for explaining code, and then they end up becoming technical debt in and of themselves. So yeah, that's my take at least. So we want to match IIS, I think, or SSI. And what does this take again? This takes node, index, res, and scale res. I see. Oh, that doesn't help me actually. I could probably just give it the op node, right? How did I do this again? Okay, so this is the op node, yeah. Wait, this is really funny actually. We can just get rid of this stuff all the way up here, right? Yeah, so this matches up with that. This matches up with that. And then this matches up with yeah, okay, we can just get rid of this. This is so funny. So we can do... we can give it, I guess, node. Or root, even. Yeah, we can just give it root. I don't even care that we're like... Oh, wait, no, we have to give it tile dist. Or, so we give it that, and then give it... tile index, and then tile scale. Yeah, that's really funny. I forgot I can just refactor that to do this. Yeah, if you've ever like read a comment and then it says something and then you read the code and it completely disagrees, that is like the perfect example of what I want to avoid. This is a really funny match function, by the way. Okay, where else do I use a switch block? Here. Yeah, we can just match the same thing here, huh? Yeah, so that one makes sense, that one makes sense. That one makes sense, that one makes sense. This one I can replace, I believe. Right? Oh wait, no, this one I cannot replace. are these matching again? These are matching add. I can't do that one. Okay. I think there was, or let's look at case. Yes, that one. This was the other instance, I see. Yeah, we're matching another scaled index here. Yeah, so this is literally scale index, so we can just nuke this real quick, and then we can go back to the other one that we fixed a second ago. Yeah, we can just copy this line. We can. We can just do scale index here instead of SSI. Or wait, IS. We should rename these real quick. This is definitely wrong. I got messed up. ISS. Okay, cool. Let's make real quick. Let's make sure the tests are the same. What's good, Arman? Good to see you. Okay, hopefully. Okay, cool. It's all the same. Probably run the test. Okay, life is good. Factoring, duplicate, IS and IS code. Yes, cleaning up. Okay, cool. So that's all of the LEA stuff that I care about for now, at least, I think. Which is quite a crazy feat, actually. Yeah, I guess we could get rid of this lack of unknown thing. Or like we could get rid of this unknown instruction thing. I'm not really sure what I want to do with this though. I should probably just panic on null pointer. Yeah, I'll just leave that as this. I don't care enough right now. Yeah, I need to fix the multiply operand stuff here, I think. I need a special case for that. Because imul is stupid. We don't like imul. Yeah. Yeah, so we can do it the one operand form way. Oh, wait, actually. The other thing I didn't think about is if we have an immediate, we're going to need to stick it in a register for all of these. We can't, like a fee doesn't really... Actually, no, we can, I think we can just throw a fee at it for now. Let's look at our output real quick. Okay, that got me nowhere. Whoops. Huge for me. Okay, it should be an op, I believe. Okay, ignoring the mess. This looks fine. I think there is something to be concerned about somewhere here. Oh, it gets optimized out. Okay, well, well that's a little bit anticlimactic. Okay. There should be an instance where we generate a multiply that is like invalid somewhere. I guess maybe not. This could be just an issue that I handle as it comes up. I don't know. I could be really lazy about this, honestly. Okay, crazy stuff is happening in my DMs. Okay, anyway. So there's a 3 operand form, which is interesting. First source can be either, second has to be immediate. That's really funny. Why is there a 3 operand form for IML? Why is multiplication just such a mess? Okay. Destination is register. Oh yeah, we do need to generate this differently, I guess, huh? Destination's a register. I think that's pretty much guaranteed by the way we generate it. Source is an immediate general purpose or memory location. Are you optimizing already? Yes, to some degree, but also this is just like a correctness thing. I need to I need to figure out how to multiply, because I don't know how to multiply. Which one do we care about? We care about this. Oh, actually, that should be fine then. I think the way I generate it. I think I can just not worry about this and I can just push it to the side and like, it will be none the wiser. Okay. So I think there's one more little optimization I wanna make real quick, which instead of multiplying by 1, we should just we should just move the thing into the damn thing. Yeah, okay. So we can just treat multiplying by 1 as a move pretty much, I think is the plan. Guess we don't need to like write more tests for this. Okay, let's make a tile real quick. Week reminder. Oh, what's good, MR Pro? Good to see ya. You're capable of achieving your dream as long as you believe in yourself and doing what's required. Good luck. Thank you. Same for you as well. Okay, let's... Alright, amazing. Thank you. What's the quarter? Good to see ya. Let's throw in another tile here. What do I call this? I guess mul1 tile. Yeah, we can do that, I guess. And then we can just copy everything else. We don't care about op, I think. We can just we can just source this, right? Or we can just make this a node, right? Yeah, it's gonna just be a node. Node star. This is kind of just a move tile, to be honest. What am I doing here? Right. Is the multiply destination register? Yeah, and then just either of the operands is a 1, I guess. We could do this with. And then this would just be a move, and like life is good. And yeah, okay. Let's just steal this. Let's go to the top of the LEA pile. I'm going in the wrong direction. Yeah, I should have just gone top. Okay. Okay, let's paste. Do that. Okay, we can do that. Tile is OM. How did I paste that? Okay. Okay. Apply is gonna be a little bit silly. We just make a move. So we have we can copy some stuff from here pretty much. Let's start with that. We don't care about that anymore. But we can instead, or actually, there's a source. Instead of the stuff in here, we change to comma. We want tiles source, I think. Yeah, we should resolve source, obviously. Okay. I think that's solid. Yeah, okay. Let's go source, dest, and then we just wanna we can copy the boilerplate from, well, anything else actually. Let's just steal everything here. Let's go size, paste there. Instead of a load, this should be move. Which is, well, the same thing, I guess. Okay, yeah, wonderfully generated. Okay, so we just want to multiply. So we can just copy this match. Okay, so we set dest. We have reg source. We have op here. Actually, we can definitely copy from a different part of our code. Yeah, we can steal this, actually. But we can change the stuff in there real quick. Let's do that real quick. So let's multiply. We should do left immediate and right immediate instead. Let's change it like that instead. So we rename everything. Okay, we can get that. So we want okay, can I like select things? Thank you. Okay, so if not so we want that, right? So if neither are an immediate, then it doesn't match. Okay. So we want to check if left immediate value should equal 1. And then we return true here. We want to do the right immediate version of this as well. But instead, the other thing we need to add is we need to set source. So this is left in, or no. This should just be op get right. Right, yeah. And then if it's right, then we want to set left here. Return false. Okay, cool. I think that's all we need here. Anything I'm forgetting? Forgetting to add this to the to the list. This should go before all the LEA stuff, I think. So you can, what do I call this? Mol1 tile? Yeah. Yeah, okay, that makes sense. What's good, Frothy? Good to see you. Actually, no, I should put this somewhere else, I think, right? I should probably throw it here, maybe? Yeah, because if it is a LEA with a bunch of other stuff it can match, I would like it to match that at least. Yeah, so let's put this here instead. I wanted to match this before it matches index scale, because then that would multiply by 1. Yeah. Good to see you, Frothy. It's been a while. Hopefully you've been doing alright. I think everything I have here is solid. I don't think I need anything else. There's something else I was thinking about, but I forgot what it was. Grinding as well, good stuff. Yeah, good to hear that you're doing well. Alright. What changed in here? Is that correct? That looks correct to me. Yeah, okay. I feel like there's something else that I'm missing here that's bugging me. I don't remember what it was, but I'm definitely missing something somewhere. I don't remember what it was. Fuck. I don't know. Let's just add everything real quick. First try. Add mol1 tile. Okay. What's this, Sony? Good to see you. Welcome to the channel. How are you learning this stuff? A lot of this I have context from like a compilers class I took in the past. That combined with like just miscellaneous stuff that I've been like, or I guess like miscellaneous stuff from various textbooks. So like all of this stuff here, I like have an idea of what it's supposed to look like from the class that I've taken, but in terms of like very specific implementation things, I'm still rough on the edges there, so I need to like, I have like reference material of some sort, whether it be like a textbook that I can like relearn the theory properly, or like my professor's previous slides, which I've been relying on a lot for instruction selection here. Do you ever regret using C++ and not C? To a degree, yeah, but I regret using C++ over Rust sometimes, honestly. I think Rust makes a lot of sense for these sorts of projects. C, I think I would run into a different type of the same problem. Because I think like, part of the appeal of using C++ is I guess polymorphism is like actually quite useful here. And that's something I would lose with C. And that would cause a pretty big problem, I think. Rust I can get around that with like the enum types, because Rust enums are like really, really powerful. But in terms of like C, I think that is the biggest thing it would be missing. And I don't understand C well enough to do that, unfortunately. Also, a lot of compiler infrastructure is in C++, so I'm also using this as just practice to get better at C++. What was the thing that was bugging me? I forgot what it was. Damn it. Crap. What are your project goals? Re-implement a lot of LLVM's optimization passes and just have a compiler that I guess competes to some degree with like the mainstream C compilers at least on the subset of code that I'm writing. Okay, what am I doing here? Auto vectorization. That might actually be something I try out at some point. That is terrifying, but also like hell yeah, I'll do it. What am I missing? There's something. Oh yeah, I remember now. I can get rid of this like double exclamation thing in a lot of places, I think. How are you building the elf? Oh yeah, I missed that, my fault. I will just output to or I guess, what do you mean by that, I guess? Like, my LIR is like kind of close to just like straight assembly. So I just do a little bit additional processing on it and I think it's pretty solid. Okay. Yeah, we can just not that and we can equals, right? Yeah, let's just avoid this double mess thing. Let's do that, space, caret, or caret, space, not, and then. Okay, let's replace that with that's not one. Yeah, this should be valid, I'm fairly sure. You're generating assembly to use the assembler? Yes. I'm just gonna vomit out assembly and call it a day. We'll just call more. We will just use whatever system linker and assembler, I think, to get it done to an executable. Actually, let's make sure tests still run real quick. Make sure I didn't break anything with this. Okay. Surely nothing breaks. Okay. That's what other compilers do? Yeah, that sounds correct to me. Okay, so we can do okay, let's, what do I call this? By 2, not var XOR not var. Oh, wait. Oh, that's really funny, actually. Can I just paste this again? And then, like, escape character. Or actually, I don't understand this. Okay, let's just write to a temp file. So what is happening here? What the fuck? I don't know. Do you stop doing the LeetCode on stream? Yeah. I just kept getting rage baited by the daily Loki. It was not worth the time in any capacity. Can I just like do like that? No. Can I like... Oh, it's the last one that's... Oh. What the fuck? Git commit. Ah, there we go, yeah. Good comms, thank you. Let's just... bye-bye, not var, XOR, not var. There we go. Okay. That was the thing that was bugging me. I've been doing a lot of these things very hackily, at least. Yeah, that's... I've been using the not operator as a one character cast with compares, because I'm doing equality comparisons and I'm doing XOR compares, I guess. So yeah. Okay, what else do I wanna... What else do I wanna do here? I think that's about it for instruction selection, to be honest. I feel good just merging this at this point. Also, like, low-key, I want to chill today, so it might make sense to call stream early. Yeah, let's go here. Yeah, I'm doing pull requests for no good reason. I need to push. Why did I do it here? Okay, we pushed. I'm making a tree structure to process words. Not quite. I guess it's less in terms of like, or I guess sort of, I guess. Whereas instead of like at the parser level where you're doing it so you can like generate a memory representation of the program to begin with, here I'm trying to map my optimizer language down to assembly, and it doesn't map one-to-one. So I'm generating trees and then I guess covering trees with the largest possible, I guess, tiles, if that makes sense. And the idea is like I can use that to generate as few instructions as possible on the tree. And that gives me a more efficient mapping than just macro expanding, I guess, the optimizer language in some way. Okay. Trees essentially represent different decision paths for mapping. I guess sort of. Let me just like draw this out. It's kind of like an AST, but like less messy, I guess. Actually, it is kind of just an AST now that I think about it. Or, not really. Not really. Sort of. It's sort of different. So like, if we have like, let's say, what's a good example here? Let's see, like A equals 1 plus 2, and then like B equals A plus, or A times 4, for instance. Yeah, so we'd represent this, we'd start with the B. So we have B here, and then this is assigned from a multiply operation that takes A and then 4. And then we also have this A here. So this A comes from an add operation on 1 and on 2, for instance. What's good, H? Good to see you. Yeah, so this is like what the tree would look like. And then what we have is like, we've defined a bunch of tiles. So like a bunch of rules for like eating up a portion of the tree, and then like what the remaining tree would look like. So like an example tile here, we have a ×4, so we can cover this section with an LEA pretty much, which is a load effective address instruction. So this is B equals LEA, or I guess, what am I doing? LEA from A, comma A, comma 4 into B, for instance. These are registers, I guess, if we wanted to be really pedantic about it. Yeah, so they'd be that, and then we need to figure out from A downwards, and then this also gets covered with one tile, like this. So then this becomes this would be like move. I guess we could cover this with an LEA as well, is the really funny thing. You know what? Let's do that. Actually, I think that is what I do. Actually, let me check. But there's like different tilings with like different efficiency, I guess. Let's see. Expected should be an LEA 01 surely, or 00 rather. Right? Wait. No, it's in here. Okay, okay. Scared me for a second. There has to be. So this is just. There should just be SD, right? Oh, we don't generate that actually. I should probably generate that, huh? That could be a good tile. For now, let's just assume this is an add. So we move one into A, and then add L. We add 2 to A. So then the final instruction set that we get from covering this tree, we have like this. Let's like move that there, and then let's copy this, and then that goes under there. So that is kind of what we have done pretty much, and the tree is necessary because these instructions could be like scattered in some other order, and that would make it hard to do this sort of maximum matching pattern, I guess. Let's erase this real quick. Yeah, let me add LEA for addition. Yeah, I forgot about that actually, or just for like adding 2 things. I swear that was a thing though, right? Yeah, let's check out Godbolt. Yeah, or wait. Okay, well that gets folded out. Okay, well, how do I get it to generate an add? Let's give it J. Oh boy, okay. Okay, well they're registers, so that's really annoying, but I guess that makes sense. So, oh well. I guess we'll have to add by hand. What a shame. Yeah, okay. So I think I'm good to just merge this. I'd be pretty happy with that and just calling it a day. Yeah, okay. Huzzah. So I think that means we're done with tree tiling, pretty much. Yeah. So that actually gets us a pretty decent chunk into the backend now. So I guess I could do like a little bit of like diagram drawing. Let's just pull that. Oh boy. Okay. Okay, so I'm just gonna draw what we have left. That is not the size I want here. Okay. So it's been long enough since I've last given the compiler spiel. I feel good about this. So we have a source language that is a giant brush size. There we go, much more manageable. So you have like the C language here, and then we have x86, 64 back here. Yeah, so those are the languages. I'm gonna draw out what we have infrastructure-wise so far. So I guess we could do all the different languages, or I guess like different memory representations in between. So we have an AST, and then we have what I call like HIR, which is just like a simplified AST. I had a concrete reason at one point for doing this, and then I just gave up. So it's kind of just like AST part 2 pretty much. And then we have like MIR, which is the optimizer language. Right now we have like LIR. Yeah, let's draw that here. Yeah. So what we do is we start, I guess the red arrows will be like what I call the front end, I guess. So this is like parse. So you parse it here, you like simplify here. And then here, I guess we just code gen, I guess. It's like, I don't really know what else to call it. Or I guess CFG. Yeah. How much time a day do you work on it? Usually I give myself like 2 hours. Today is definitely a lot shorter because it's kind of just an awkward amount of work that I've done. Okay, so the red arrows here are our front end, I guess in air quotes. We'll use blue for like the middle end, which I know doesn't really make a lot of sense, but we optimize here. There's a lot of different optimizations. I've only done a couple. And then, oh boy. Yeah, so this is where we are now. Green arrow, this is the back end, I guess. So this is like instruction selection and then linearize. And then this is, I guess, what we have so far. We've gotten to this point. So there's a couple of things we're missing. I will just do dark green for this. I guess the two that are like 100% required here, the first one is like register allocation. Because we're still using variables, but hardware only has a certain number of registers. So we need to like compress those down somehow. So that's the purpose of that. And then we need to just like do final code gen cleanup things. So cleanup / code gen. Nice compiler name, thank you. Good to see you. Good to see you today. Yeah, so I think the next thing I will work on in the upcoming future is regalloc. As well. We can't really do much else without that. There's some other things I would like to add, so like people optimization, which is just like, I guess, going over the code with like a fine-tooth comb and just like making some small optimizations here and there. That would be nice. The other thing I want to try learning about is like scheduling. And this is something I've just historically never learned about, so it's gonna be a good time to learn about that at least. I think what I will do is first I'm gonna do regalloc. then I'm gonna do the cleanup stuff. And then I think I'm gonna take a bit of time to write a couple more optimizations because that's all the cool stuff for me. And then I think I will cover these later. Yeah, in terms of like what's next on the line, at least. Yeah, I don't really want to start any of this right now, so that's a little scary. There's a lot of stuff that needs to go into Regilock. Yeah. I think the fact that I guess it's kind of SSA-ish at this point. I think that will help out a lot with, I guess, figuring out how to coalesce registers down, but we might still make a mess. We'll have to see what happens. I'll also need to like, I think this is where like SSA destruction in air quotes happens. There's like a couple of like edge cases I need to handle as well. I don't really know where to handle them, but I will need to handle them eventually. So yeah. How long did it take you to master Vim? I think it took me half a year to become comfortable in it and a year to become like remotely fast with it. Right now it's been like 1 1/3 years, or 1.5, almost 1.5 years, I think. Yeah. But yeah, I think I'm gonna call the stream here, unfortunately. I think this is a pretty solid stopping point. Did it pass? Yeah, okay, cool. LLVM's greedy register allocation. I think that's what they do right now. I'm fairly sure it does do that. Huh. Glup. I remember LLVM doesn't do, LLVM doesn't, I know they don't do, graph coloring, but I don't remember what they do specifically. Sure, okay. That's really funny. I guess that makes sense. I think they did do linear scan last time I remembered. PBQP could be interesting to look at. That's a little bit scary. Yeah, maybe I could, yeah, I think this is what you're talking about, the linear scan one. Anything interesting here? Oh, okay. Something different? Interesting. Okay. LVM blog post, bet, okay. Yeah, we could do this sort of. Ooh, okay, interesting. Basic, greedy. No longer be linear scan. Interesting. Oh, this is like ancient. Wow, okay. Yeah, I guess I could take time to read this, yeah. It's very surprisingly well. Your tweak. Da da da. Expensive data structures. Yeah, you need to do a lot of stuff here, which is annoying. Should only rewrite virtual registers to assign physical registers, but it knows many other tricks. Like reloading a register. Better, we'll clean up the code by reusing the first register. I guess I need like... Do I need like liveness anyway? If I'm like... using like... If I'm sticking fees everywhere. Avoid making obvious mistakes. Sure, okay. I guess this makes sense, yeah. A large live ranges first. That makes sense. Yeah, this... I am just like reading down this, unfortunately. I'm not gonna like read out loud, but yeah, the blog post is in the Discord. So if you wanted to like read along, I guess that might be the play. Yeah, okay. I guess that's pretty interesting. Is there like a proper, just like, there needs to be better LLVM documentation on stuff I can steal. I see. Some papers, okay. Huh. Yeah, this, okay. Is this? No, that's not the one. This is the paper that, or this is the talk that comes with that, I guess. Okay. Yeah, so this is like kind of, it's like sort of what I'm doing. I'm just kind of skipping scheduling for now. I'll throw that in later. Linear linear scan is not in fact linear is really funny. Okay. Just K coloring. Oh, that's not what I want to click. Interference graph. Da 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 da. Yeah, that's expensive. Spill code placement's more important than coloring. Yeah, that makes sense actually. We need to figure out what we're spilling, I guess, right? Or what and when. Need to model aliases and overlapping. Yeah. Yeah, that makes a mess, yeah. So we assign a virtual register and we insert spill and fill, yeah. That makes sense to me. Oh man, this is difficult stuff actually. This is quite difficult stuff as a matter of fact. Okay. Explain the live range. Yeah, that makes sense. Insert copies. We need to do this anyway, I think. Yeah, and then spilling is like annoying, so we don't want to do that. Change instructions. store instruction with address right back. Okay. I see. So we rewrite. Yeah, okay, that makes sense. Rearrange the instructions. Yeah, that makes sense. Yeah, okay, that makes sense. Okay. See, it does that well, but it does it, or it does that, but not well. We can't really do that. Okay, yeah, that makes sense. Yeah, people, the rewriter. Okay. Yeah, sure. Okay. So order live, okay, yeah, that makes sense. So that's like greedy in terms of live ranges. Wait, what? Okay. So order them by size. So 2 and 3 are the longest ones, right? Yeah. So allocate those right away. So then we try to stick reg 1 in. So the smallest spill weight, I guess, is 2 here. Or I guess we save that, rather. And look for places to split. Interesting, okay. Okay. I guess that makes sense. That could be cool. Okay. So process live ranges in any order. Long first. Okay. Yeah. As long as first. That means we still need to make live ranges, but that's fine. Yeah. Okay, that makes sense. Splitting around loops. Yeah, okay. So the cold call, we don't want to affect other code, just spill around the call. That makes sense. Okay, sure. Yeah, this I do not understand yet. Okay. LVM 3.0 Regalok runs in the same compile time as linear scan. Interesting. Okay. That's crazy, actually. Okay, and then benchmark. Yeah, sure. Okay, cool. Okay, I guess that kind of makes sense. I guess that could be something I'd look at. Yeah. I'll have to read more on this in the future. I might just do a lot of reading next stream, I think. That might be the play. We might actually just not write code. Yeah, that'd be a pretty funny outcome. Anyway, yeah, I think I should probably head out. I'm quite cold and quite tired. Yeah, thank you all so much for showing up today. If you like this stream, make sure you give the stream a like. That's English. And sub to the channel if you haven't. Also in the description is the link to my Discord. You should join that. Everyone's pretty chill. You can also get pinged when I go live, which is way better than whatever YouTube has. Yeah, aside from that, My GitHub and LinkedIn are in the description as well. Add me on those to stay up to date with what I'm doing. Yeah, that's about it. Take care, y'all. Take it easy. Have a wonderful rest of your day wherever you are.